if I know that V equals 1, okay? What's the tension? And what is this reaction force? How much is it pushing back, okay? So how am I going to work out tension? How do I get that from these two equations? I should just add them. That'll cancel out the normal force, okay? So I'll go 1 plus 2, right? That'll give me on the left-hand side 2t. On the right-hand side, it'll give me, let's see, 2g on root 3 plus 4 times v squared, and v is defined as 1 in this particular case. So that'll be 4. Okay. So then you get t is equal to, you divide, and this will be whatever it is depending on whatever gravity you want. Okay? You rehearse the same thing. How do I get n? Instead of adding, I should subtract the equations. So I'll go 1 minus 2. Okay? Actually, I should probably do the other way. Yeah, no, that's fine. Yeah, that's okay. So you get 2n equals, and then everything's just round the other way. Okay? You're going to get 4, no, hold on. Is that right? 1 minus 2? No. 2g on root 3 minus 4. Right? You just go from there, and you sub in whatever value you want for that. Okay? So this is how much the cone is pushing. Okay? And this is how much, where was it? This is how much the string is pulling. Okay? Last question, almost there, the most interesting one. Okay? I want to know how fast I can spin this thing so it actually will stay on there. Right? Let me pose you this question. At what point, like in terms of all this, at what point would it lift off? What point would it lift off? It's when the normal, right? When it's no longer exerting any force out. Like the cone, it stops touching the cone, right? So therefore, n should be 0, right? So if I want to solve for n equals 0, n equals 0, that's what I'm trying to find, right? At that point, it stops, okay? Where am I going to put this into? Probably this one? This one? Because then you're going to get, well, t minus 0 equals 4v squared. Okay, so now I'm going to solve for v. What's the tension? T on 4 equals v squared. Now, don't confuse it. Don't confuse it with this part here, right? Because this is a particular tension for a particular speed. What's the tension here? Where did I get this from? This is equation 2, right? If you go to equation 1, when the normal force is 0, then your tension is just 2g on root 3. 2g on root 3 divided by 4. Okay. So cancel. V squared equals g on 2 root 3. So this will be the velocity I can go, and at this particular moment, I'll lift off from the cone. Okay? Can't go any faster than that. That's your upper limit.